Hi everyone, welcome to my channel. So with continuation of our DSA series, I'm back with my another DSA problem from lead code. So today I have picked one question, that is the name of this problem is reverse integer. So this is very basic problem, okay, which comes under medium level, okay. So this is very basic. What we need to do here is we are given a integer number, okay. As you can see here, we are given in this question we will be given one integer number, okay. And what we need to return, we need to return the reverse of this number, okay. For example, here uh, 1, 2, 3 is there. Then what we need to return? We need to return the same, we need to return this particular number in the reverse order, that is 3, 2, 1. Okay. But one one thing we need to make sure here, that is already mentioned here. So we need to note here that if reversing x causes the value go outside the signed 32-bit integer, then we need to return 0. Okay. So there is one edge case here. Okay. So what is the edge case? So integer has some range. Okay. So the if we are storing any value in the form of integer, then the minimum then the what is the minimum value of integer? Minus 2 to the power 31. And what is the maximum value of integer? 2 to the power 31 minus 1. So the question here, the question says is, if the reverse output causing uh, exceeding the given range, then in that particular case we need to return 0. Okay. So this is the problem we need to solve here. Okay. So let me take you through my slide, and there I will explain you. So here I'll explain you the logic how we can proceed with this question. Okay. So I'll take the input here. Suppose we are given input number as 1, 2, 3. 1, 2, 3. Okay. And we need to return the reverse of this number, that is 3, 2, 1. Okay. So we need to return 3, 2, 1. That is the reverse of the same number. Okay. So how we can approach this question is, first of all, what I need to do here, we will apply the simple logic that we already studied in our childhood classes. Okay. First of all, what I need to do here is, in this number, I'll pick the rightmost digit. Okay. Rightmost digit. And I'll store that digit inside the digit variable. Okay, I'll define a digit variable, and inside this digit variable I'll assign that the rightmost digit of this number. Okay. Then after that, what I'll do is I'll apply one logic here. Also, I'll define one more variable, that is reverse. Okay. Initially reverse will be 0. Okay. And I'll define a while loop here. And inside this while loop, I'll run a condition until x is not equal to 0. Until this x is not equal to 0, we will execute this while loop. Okay. So what we need to write logic here is, first of all, I will pick the initially digit how we can pick the digit, what will be the logic for picking the digit. We will do x modulo 10. So modulo gives us the remainder. Remainder means the last digit of the number. Okay. So after that, what I'll do is I'll do reverse is equal to reverse into 10 plus digit. Okay. So I'll do this. So currently we are having reverse is equal to 0. Okay. We are having reverse is equal to 0. Okay. Let's erase this. So initially we are having reverse is equal to 0. So 0 into 10 plus what is the value of digit we are having. So let's calculate here. What is x? We are having 321. 321 modulo 10. So this one gives us the remainder. So if we will execute this uh, action, then what I will get 1. Okay. I'm so x is 1 2 3 here, not 3 to 1. 1 2 3. 1 2 3 modulo 10. So in this case, what I'll get 3. That is the last digit of this number. Okay. So here digit is what? 3. So 0 into 10 is equal to 0 and 3 plus 3. So what will be the reverse? Reverse will be the 3. Okay. Now, now again I'll no now after this what I'll do is, so we were having number 1 2 3 as the input, and we have stored this last digit into reverse. Now we do not need this digit anymore. So we need to remove this digit from this number. So how we can remove the last digit? So we can remove by this particular line of code. We'll perform this action. X modulo 10. What is x? 1 2 3. 1 2 3 by 10. What it will give? 1 2. It will so uh, this provides the quotient. Okay. So this particular code will provide the quotient. Okay. So what I'll get? 1 2. So so I have removed 3 here. Okay. So now what is the value of x? 12, not 1 2 3, because we have removed this 3. Okay. Now we will back to again the same while condition. Again I'll check while x is not equal to 0. Okay. Is x not equal to 0? Yes, this is not equal to 0. Still this number contains digits. Okay. So again I'll pick the last digit of the number, that is, what is the last digit? 2. Okay. So I picked the last digit and stored into the digit variable. Okay, now I will execute this particular line of code. What? Let me erase first the previous one. So what is the value? What is the value of reverse? We are having the value of reverse is 3. 3 into 10 plus what is digit we are having? 2. So after execution, what we will get? 32. Okay. Now we have we have done the operation of last 2 digit numbers. Okay. We already removed this last digit number, and now I need to remove this 2 also, because I already stored this 2 also. Okay, so how we can do? We can remove with the help of this particular line of code. So if I'll perform this operation, I mean 12 by 10, then what I'll get? 1. Okay, I'll get 1. Okay, so here what is the value of x now? We are having the value of x is equal to 1. So again I'll come to this while condition, and again I'll check whether x is not equal to 0. Yes, x is not equal to 0. Still the value is still we are having digits left in the x. Okay, so again I'll pick the last digit. Only one digit is left, so last digit is 1. Okay, now we will execute this particular line. What is the reverse? We are having 32. Okay, 32 into 10, thus what is the digit? 1. Okay, so what will be the answer here? So what will be the answer here? 32 into 10 is 320 plus 1. So 321. Okay, so so we got the 321 as the answer. Okay, now we don't have any digits left in the number, so we don't need to execute this particular line of code. Okay, so uh, so we were having 1. Okay, after removing this 1 also, what we will be having? We will be having 0. Okay, so we are no left digits inside this number. We have covered all the digits of the number. Okay, now we will go to again, we will go to this while loop, and again we will check is x is not equal to 0. Yes, now at this time this condition becomes true. So okay, this condition becomes false. Okay, if this condition becomes false, then we will come out of this loop and we will return the reverse. And what we were having the value of reverse? 321. 321. Okay, so this is the logic of this particular problem. But there is one lack in this problem, is what? We are not checking the edge cases. Okay, as in the question it was already mentioned that if the reverse value will exceed from this range, then we need to return 0. But in this logic we are not applying that uh, edge case scenario. Okay, so we need to apply that logic within this logic as well. Okay, so how we can do is, first of all, uh, how we can do is we need to check, we will check if the reverse is, so what is the value of we, so the minimum value is this one. So what is the value of minus 2 to the power 31? We are having this particular range. Okay, so this is the minimum value. Okay, this is the minimum value. And what is the maximum value we are having? 2 to the power minus 31 minus 1. So what is the value of 2 to the power 31 minus 1? This particular value. Okay, so if our reverse output will exceed between these two range, then in that case we need to return 0. Okay, in that particular case we need to return 0. So how we can apply that logic here is, so if the reverse is greater than this particular number. Okay, at this time we are not we are not uh, including this digit. Okay, so how we can get this number? There is one value. integer dot mean value, mean value, mean value. So this, if I write this particular line, then this means it will provide this particular value itself. Okay. So I want till here. Okay. So what I'll do, I'll divide it by 10. Okay. So it will gives me this particular range of value. Okay. Now, if this if reverse is greater than this particular number, okay, and I'll apply one more logic here, okay, or integer or reverse is equal to integer dot mean value and reverse is greater than, not greater than, less than -8. In that case we need to return 0. We need to return 0. Fine. So this is for the lower case. Okay, this particular code I have written for the lower case. So again I'll write the same for the upper case. Okay, if reverse reverse is greater than, here it will be less than, not greater than. If reverse is greater than integer dot max value or reverse by 10 or reverse is equal to integer dot max value and reverse is greater than 7, in that case we need to return 0. Okay, so this is the two edge cases. Okay, this particular code I have written for the lower case. If it will exceed below from this particular value, then we will return 0. Okay, for upper case, if if the reverse value will exceed by this particular value, then we need to return 0. Okay, now let's check the code now. So now we will dry run this problem. So we are given x is equal to 1, 2, 3. Fine. Now we need to return 3 to 1. This must be our output. So this is our target return type value. Okay. Now, so I have written a Java, this particular code in Java. Okay. So inside that I have defined one method, that is reverse. So inside this method I'm passing one int value, that is this value I'm passing here. Okay. And I have defined one reverse variable, and initially I have assigned with 0. Now I have defined one while loop here. So this while loop will execute until x is not equal to 0. Okay. So now inside this while loop I have defined one digit variable. So this particular digit variable will help to pick the last digit of the number. Okay, so currently what is digit we are having? Digit is 3, because after execution of this particular line we will get the last digit of the number, that is 3. So now if I'll execute this particular line. If reverse is greater than integer max value, what is the reverse we are having? 0. Reverse we are having 0. So is reverse greater than maximum value? No. What is the maximum value? Maximum value is what? So maximum value is our 2147 214748364. Okay, so this is our maximum value. Okay, so let me write this particular 214748. So 214748 2147483 3647. 3647. This is the uppercase. And what is the lowercase? What is the lowercase we are having? 21474836448. So this is the lowercase and this is the uppercase. It will be in plus. Okay. So if this reverse is greater than this maximum value mod by 10, okay, then we need to return 0. But this condition is false, and also reverse to equal to integer dot max value. This condition is also false, and digit should be greater than 7. Is the digit greater than 7? No. Okay, so we will so this condition is false, so we will come out this loop and will come inside this if condition, that is reverse is less than minimum value. So is our reverse is less than the integer mean value? No. So we will come out this loop and execute this particular line of code. What we are having reverse? 0. 0 into 10 plus what is the digit? 3. So 0 plus 3 is 3. Now we already stored the last digit into the digit variable. So we know, so we are no, we don't need this uh last digit of this number. Okay, so we will discard this particular digit from this number. How we can discard? We will simply do x by 10. Okay, so we have discarded this digit from this number. Now again back to the while loop. Okay, so again check, is x not equal to 0? Yes, this condition is true. So we will come inside this loop. Is reverse greater than integer dot max value? No. Okay, so this condition is also false. Reverse is not equal to integer dot max value. So we will not execute this particular if condition. Again back to this if condition, is reverse, what is reverse? 3. Less than minimum value? No. This is not even in minus. So this particular condition is also false. So we will come out this loop if condition and we will execute this particular line. So now we will execute this one. reverse into 10 plus digit. What we are having reverse? 3 into 10 plus digit is what? Digit we are having 2. Okay, we are having 2. So 30 plus 2 is equal to 32. Okay, now we also stored this particular digit into our reverse reverse integer variable. Okay, so we no more required this particular digit from this number as well. So we will discard this number. How we can discard? We will do 12 by 10. The output will be 1. So we are left with this 1. So currently x is containing only 1. Okay, again we will go to the while loop and again check this condition, and we will pick the last digit number. That is only one digit is left, so our digit will be 1. Okay, at this time. Now if reverse is greater than max value, no, this condition is false. Okay. And this condition is also false. So now again we will come to this particular line of code. Let me erase first of all. Now reverse is what? 32. Reverse, what we were having reverse 32. 32 into 10 plus what was the digit? 1. 32 into 10, 320 plus 1, 320. So now what we got reverse 3 2 1, not 320. 3 2 1. Okay, so now we got 3 2 1. Okay, so only 1 is left here. So 1 also we stored in this reverse variable. So 1 also we need to discard here. How we can discard? By doing 1 by 10. We will get 0. Okay, so now x becomes 0. X becomes 0. Again we will go to the while loop. Is x not equal to 0? No, this becomes false. X is 0. So we will come out this while loop, while execution, and we will return reverse. So what we are having reverse 3 2 1. So we will return this 3 2 1. Okay, as a output. So this was my target to achieve 3 2 1. As I got this, my target value, that is 3 2 1. So this is achieved. So hope you guys understood this problem. So if you like this series, please do like, share, and subscribe. And so thank you so much for watching this video. Thank you so much.